Hello and welcome to another video. In this video we're going to be working on minimum number of operations to make array XOR equal to k for the biweekly contest. And I'm going to skip the easy problem. I think it's a little easy and the description's kind of bad, but once you get the description it's super easy to do. So we're going to start with this one. So in this one you're given a 0 index integer array nums and a positive integer k, and you can apply the following operation: change a 1 to a 0 or a 0 to a 1. Return the minimum number of operations required to make the bitwise XOR of all elements in the final array equal to k. So let's go through some of these examples, and then we also want to learn like what things in XOR you really want to know. So let's go through this one in detail. 2, 1, 3, 4, and we're trying to make a 1. So 2, 1, 3, 4. Let's show the bits for those. So for 2, it's just going to be 0, 1. We can draw it like this: 0, 0, 1, 0, 1, 1, and 1, 0, 0. And then k is 1, so this is this. So for bitwise XOR, basically all you really care about is the count of the ones odd or even. And if the count of the ones is odd, you will get a 1, and if it's even, you will get a 0. Right? So if we bitwise XOR all of these together, here there is an odd count, so we will get a 1. Here there is an odd count, so we will get a 1, and here there is an odd count, we will get a 1. Let me just make sure I did this right. Yeah, I didn't. Okay, so this should be this. So let's redo that. So here there's an even count, actually, so we'll get a 0, even, 0, odd, 1. So now we have this, and we basically are asked, transform this into this. So in order to do that, it's pretty straightforward, like how many operations you need. So, and you can use a basic thing in XOR, which is if you have A XOR B equals C, then also you can flip any of these around. So A XOR C equals B, A or B XOR C equals A, all of these, like this is all interchangeable. So what we really want is we need to figure out how to go from here to here. Like what number do we need to XOR this with to go to here, right? So if this is A, let's say, and this is B, we are looking for C, right? So if A XOR C equals B in our case, which this is A, this is B, and we are looking for C, we can use this equation, right? So we can just XOR this thing with this. So if we do this, then we will get our C. Right? And we can do that. So we just take 100 XOR 1, or is this one right here? We XOR these together, and we will get 1, 0, 1. And so this is what we need. So basically, we're like in order for this to happen, right? We need to XOR this with 1, 0, 1. And basically, we just have to figure out how many ones are in 1, 0, 1. So in 1, 0, 1, there are 2 ones. And notice these are the, like, if you notice where locations these are, this is the 0-bit and the 2-bit, right? So if you notice, these are the ones that weren't the same as k, right? Like this was not the same, and this was not the same. So if this part doesn't make sense to you, totally fine. What you can do is you can just XOR all of your numbers, get some number, and then just compare bit by bit to k, and every time there's a bit difference, you need to make one operation. And that's kind of the key for XORing, is for every bit, you're never going to need to make more than one operation, right? You're either going to want to change a 1 to a 0 or a 0 to a 1 one time. Because changing one of these bits will change your output, right? Like if I just change the 0 to a 1, that will make it a 1. If I change a 1 to a 0, that will make it like the opposite, and so on, right? So it's very easy. I can change any 0 to a 1. I can change any 1 to a 0 to change this bit. And so that's kind of basically all you need to do. Is you might have thought like I need to sum up all of these and compare it to this, but you don't really need to do that. You can just XOR all of these numbers and then use this formula here. So you just XOR all of these numbers, you get a number here, you XOR these numbers together, and then you get your like result, and in your result, you just count how many 1-bits are there. So we can do a few more examples just to make this a little bit clearer, and then we can code it up. But yeah, that's the main thing you need to know for XORing is just how it works and how many bits you need. So let's go through this example here, this 2020. Well, this one's actually going to be kind of basic. Let's just try some other example that is not so basic. So let's just say we have like 2, 3, 5, 15 maybe, and we're trying to get like 10. So let's XOR all, let's like first look like what it needs to look like, and then we can figure it out. So 2 is going to look like 0, 0, 1, 0. 3 is going to look like 0, 0, 1, 1. 5, 0, 1, 0, 1. And 15 is all ones. Now 10 looks like, let me think. I think it's like this. Yeah. So once again, we're going to XOR all these just to see like what we get. So, or like I said, you could just look at the count. Like you don't even have to XOR all these. Like you could say like, okay, the count here is odd, so this will produce a 1, and we want a 0. So we know that's one operation that we need to change, one of these. The count here is odd, so that will produce a 1. We have a 1, so that's fine. The count here is even, which will produce a 0. That is a 0. And the count here is odd, which will produce a 1. So we know the answer here should be one operation, but let's continue on because like this is kind of hard to do, right? You could do that as well. You could literally go through every single index, add up the ones and compare it to here and check for equality. And if they're not the same, then you need one operation. But let's just actually XOR these to make it easier. So if we XOR, like I said, we get 1, 1, 0, 1. And there is only one bit we'd need to change to make it look like this, right? So you could compare these bit by bit. That also works. But like I said, you can just XOR these, get the difference, and the difference is how many bits you need to change. So if we XOR these, then we get 1, 0, 0, 0. And this is the only bit we need to change. So like I said, once we get this little number, we can just check how many 1 bits are in here. And that's the answer. So there's 1 here. And so that's pretty much all you need to do. So as long as you know like how XOR works, and I think XOR is the most important bit manipulation, so you should definitely know like all the tricks and stuff and how it works. If you had to know one, this is the one. Okay, so now we can code it up. So we can just have a result variable, and we can just say for num in nums, let's just XOR it with our result, and you can do a shorthand like this. Now we want to XOR our result with k. And now that we have this variable, now we have to just figure out how many ones are in here. So we can say like, maybe result wasn't the best thing. Maybe like we could have this as like this, a little bit more descriptive. Now we could have a result variable. So we could say like while XOR is greater than 0, let's just keep checking for 1 bits and keep shifting it. So we can just say like result plus equals XOR and 1, basic bit manipulation, and shift it to the right. And you can do a shorthand like this. And finally return result. And that should do it. And there we go, and pretty good. So yeah, I think the main thing that people really don't know from XOR is this one, right? So if this is the case, any one of these can be flipped around and this is still valid. So this is valid and so on. I think this property isn't like, I don't know like the official name for it, but I think I basically learned this while doing some problems. So like I said, this is a good one to know, where you can shift all these around. And I think if there's multiple things, it also works. I'd have to double check that. Like I think if this is the case, then these can also be shifted around. So you can do something like this. I'm pretty sure like, you know, if you have more numbers, it still works too. So I'd have to double check, but I'm fairly confident this is the case. So anyway, let's go through the runtime. So for this first part, we're basically looping through nums, which is just O of n. And then the second part, this part right here, it depends on how big the biggest number is. So here's 10 to the 6th. So we can say, we can call this like another variable, maybe like big or something. So basically be like log of, this wouldn't be this wouldn't be the biggest number. This would be like the biggest number you can make with k and, so I guess k would be a good variable to use. No, I think it would be like it would be basically like what's the biggest number you can make XORing something in nums and k. So I guess these are the same. These are like the same size. So, I mean, I guess maybe we'll write something like this. But yeah, essentially, when you take all the bits of a number, that's a logarithmic operation because you're basically like dividing it by 2 every time. So it's going to be something like this. And then for space, it's going to be a 1 because we just have like this XOR variable and this result variable. So not too bad. Yeah, definitely, like I said, important to learn all the XOR operations, how it works, and what you need to do to make an XOR 0 or 1 or so on. Yeah. And if this was helpful, please like the video and subscribe to the channel. And I'll make the next few videos for this contest today probably. So see you in those. Thanks for watching.